This is a lesson on the probability and odds of an event occurring. Most events we cannot predict with certainty, but we can attempt to measure the chances of something happening with probability. Let's look at some examples. Tossing a coin results in two possible outcomes, heads or tails. There is a 50-50 chance that the coin will land on either side. Therefore, we can say the probability of the coin landing on heads is 1 out of 2, and the probability of the coin landing on tails is also 1 out of 2. We can also apply the results when throwing dice. There are 6 sides to a die, which can result in 6 possible outcomes, 1, 2, 3, 4, 5, or 6. If we roll a 2, then the probability of the die landing on 2 is 1 out of 6. The formula to calculate probability is to divide the number of desired results by the total number of possible outcomes. But before we delve further into calculations, let's talk about the history of probability. The origin of the development of the theory dates back to the 16th century. Gambling was becoming increasingly popular in French society. French nobleman and avid gambler Cheval de Mere wondered why it was more likely to obtain a 6 in 4 throws of a die than to obtain a double 6 in 24 tosses of 2 dice. So de Mere recruited his mathematician friend Blaise Pascal to figure this out. Along with the help of another mathematician, Pascal determined the following theorem. When determining the probability of rolling a double 6 with 2 dice, we recognize there are 2 dice, therefore there are 36 outcomes. We take the number of desired results, in this case we are hoping to roll a double 6, so the desired outcome is 1, divided by the possible result, which is 36. So we can come to the conclusion that there is 1 in 36 chance to roll a double 6. Specifically addressing de Mere's question, there is a 1 in 36 chance to roll at least one pair of double 6s. The probability of rolling double 6s is less than half. In this case, de Mere's best bet is to not bet at all. As time passed, the theory of probability continued to be studied and others found ways to apply it to a variety of topics besides gambling. In the late 17th century, probability also played a role in theology. According to Pascal, there were 4 more possibilities and disadvantages to doubt the existence of God. Pascal thought if God did exist, believers would be rewarded, and those who doubted his existence would be punished. This theorem is otherwise known as Pascal's wager. Probability also played a role in the judicial system. People believed that one could rely on the analysis of truth by using the mathematics of probability to determine the credibility of judges. A judge's qualifications were taken into consideration as well as their past ability to reach a correct decision. If a judge was believed to be competent and trustworthy, there was no reason to have a jury trial. August Zillmer, a German life insurance actuary, began to apply the probability theory to calculate life insurance values. His calculations are based on ones developed by Tentens, a mathematician, philosopher, and actuary. Later, this method of calculation became known as the Zillmer method. This method was adopted by insurance companies in Germany, but its use did not spread to the United States. In the early 1900s, the probability theory was looked upon to determine problems associated with telephone traffic. The popularity of this rather new invention faced complications as too many people were trying to dial out to be connected to someone at the same time. Danish mathematician, statistician, and engineer A.K. Earling developed a probability formula known as Earling's formula. By calculating the number of calls made at the same time to the switchboards, he measured the time between incoming calls as well as the expected duration of them. Earling was able to estimate the load of telephone traffic and determine possible delays callers may experience. Probabilities may be dependent or independent of each other. An example of an independent event is trying to determine the probability of drawing a black card or an ace from a deck of cards. Each of these events are independent because picking a black card is separate from picking an ace. Being dependent on each other is imagining a bag of marbles that contains 6 marbles that are white and 6 black marbles. On the first try, a person has an equal opportunity of picking a white or black marble, but if we continue to pick marbles, the probability of picking a certain color is reduced. If we draw 3 black marbles, the likelihood of drawing another black marble reduces from 6 out of 12 to 3 out of 12. Majors of the Full Sail software development program use probability to identify possible outcomes of a program that is being developed and also expose possible risk factors and errors that may result. By utilizing the probability of success, they are able to project the outcome based on data gathered from previous successful software projects. Also, in the simulation and visualization major, they are responsible to carefully plan and develop virtual simulation models. Since virtual simulation models are often used by the U.S. military, and also to train pilots to fly a plane, it is critical the program runs smoothly without any errors. Today, probability is used in daily life. It is used to determine risk assessment in financial markets, estimating reliability, and even predicting the weather. So in closing, keep in mind that although it is possible to calculate the probability of an event occurring, that the calculation is never guaranteed to be accurate.
Created using Powtoon.